Uh, Welcome. This video covers LoRa fine-tuning with Onslaught. LoRa stands for low rank adaptation. It trains only 1-2% of the model parameters using small adapter matrix, and well, this is much faster and more memory efficient than full fine-tuning, obviously, because you won't have to, like, as I said, full fine-tune everything. We will use the exact same models, the exact same data set as in the previous video for the small 135 full fine-tuning video. If you haven't watched, please, you could go and take a look at that as well. For the comparison. Yeah, let's get started. So when setting up the LoRa configurations, the key difference is our configuration use LoRa, which is true. Uh, if I could show you, yeah, use LoRa being completely true. We are starting from here. Obviously, get your data set and get your environment all set up, installations and everything. So the LoRa R would be 16. Uh, for regularization. Uh, we target specific models: Q project, K project, V project, O project. Uh, if I could show you, yes, somewhere below in the code, but would eventually get it. You could visit my code as well. So we target all of these attention layers and gate proj, up proj, down proj for MLP layers. Only these get smaller adapter matrices attached. Learning rate is slightly higher at 2e to the power minus 4. Since we are training fewer parameters and same 50 training steps and as full fine tuning. So yeah, applying this is the model being loaded and tokenized. After loading the base model, we apply LoRa adapter. Look at the output. Only 1.25% of the parameters output is what I would show you later. The only 1.2% of the parameters are trainable. That's about 1.6 million parameters instead of 135 million parameters. And well, yeah, you might have a very basic question. How does LoRa actually work? It adds small matrices alongside existing layers. So during forward pass, the original weights stay frozen and the only small adapters get separated. This drastically reduces memory and like computation requirements. The base model remains unchanged. We can swap different LoRa adapters for different tasks on the same like base model. Uh, Applying LoRa, you could see how we fine trained, as I said. Oh yeah, here it is. QKVO proj and the MLP layers uh, with all the basic parameters all set, and loading the data set as provided before, and then building up the tokenized and trunking it together. And we start for the training comparison. So the training starts. I will show you the results. You would notice one thing: the speed. Each step takes around 12 seconds compared to 18 seconds for the full fine tuning on for the model before. That's around, how's it, like 30% faster. Loss is decreasing nicely. Step 10 shows 2. Step 25 shows 1.7, somewhere around 1.7. The learning dynamics are similar to fine tuning despite training far fewer parameters. Total training time is about 10 minutes versus 15 for the full fine tuning. The adapter files saved will be tiny, just around 2 to 5 MB compared to the 540 MB for the full fine tuning model. You can share just the adapter and anyone with the base model can use it. So after all the training and trainers being done, we start with, as I said, saving the LoRa adapter. You could just share the adapter and merging the models. You could share with the testing, and Testing the LoRa fine-tuned models have the same three questions as before. What is machine learning? Write Python, Fibonacci functions, and explain what a cycle. The quality is comparable to full fine-tuning. This is the power of LoRa. Near identical results with fraction of compute. The small performance gap matters most when you have massive data sets. We just have 500 samples over here, so it's not really massive, and need to squeeze every little bit of that accuracy. So yeah, coming to the results, as I said, you could have multiple instructions, you could have multiple questions. I asked the same three questions over here. It's actually started building up the function. It's not created. It's not exactly creating the functions. I would still have to train it on much more data, on much more fine-tuned coding data, so that it could actually start implementing and writing the function over here. But apart from that, the whole basic NLQ responses, we still have that on a very higher scale, since it's less computing power with LoRa. So yeah, uh, that's about it. LoRa, the summary for LoRa trains around 1 and 2% of the parameters 30% faster, 100% small adapter files, and quality near matchable full fine tuning. You could use LoRa when you have limited GPU memory, want fast experimentation, need multiple task-specific adapters, or have small to medium data sets around 10K SAM. So I just took 500 over here. Use full fine tuning when you have large data set like over 50,000 samples. The maximum performance is critical, and you have to have sufficient compute resources. So, yeah, that's about it. Next video covers the DPO for the preference based training. So yeah, thank you. See you in the next one.